Hello, everyone. My name is Jose Ochoa. I lead educational programs with TWIML, and I'd like to welcome you to TWIMLfest. We're excited to have you here. This session is So You Want to Teach an AI ML Course. Before we get started, I'd like to thank our sponsors for helping make TWIMLfest possible. In particular, special thanks to IBM for their ongoing support of TWIML programs. IBM has a great data science community where practitioners can connect, collaborate, and empower one another. If you're not already a member, go to twimlai.com/IBM community to join and get a month of select IBM programs on Coursera for free. Since this event is hosted on Zoom, please take a minute to note the location of the chat. We will be taking questions here and in the YouTube chat as well. To start, I'd like to briefly walk through, introduce all of our panelists, and then get the conversation going. So first up is Ana Echeverri. She's the Data and AI Experts Lab Learning Leader at IBM and lead contributor and developer of OpenDS for All, an open source data science curriculum kit. Jennifer Carroll Priestley, Statistics and Data Science Professor at Kennesaw State University, also lead contributor and developer of OpenDS for All. Robert Osazuwa-Ness, Professor at Northeastern University and research scientist at Gamelon. Robert's also the developer of Causal Modeling in ML, a course that's taught in our TWIML community. Torbjrn Nordlien, Assistant Professor in Automatic Control at National Cheng Kung University, Senior Lecturer in Media Technology at Umeå University, and Principal Investigator at Nordlien Lab. Special thanks to Torbjrn for joining, as it is the very early morning hours for him in Taiwan. And Luigi Petruno, Director of Data Science at 2U and founder of MLinproduction.com. He's also the course creator of End-to-End Model Deployment with Amazon SageMaker. All of our panelists have extensive experience teaching AI and ML courses, and we're excited to have them here to share their perspective. So to start, we'd like to ask each of our panelists to take a minute to tell us a little bit about themselves. Then we'll have a discussion around developing AI and ML courses, and we'll open up the floor for questions. But please do send your questions throughout the session. We'll be monitoring both the chat in Zoom and the chat in YouTube. So Ana, do you mind getting us started and telling us a little bit about yourself?
Absolutely. Hello, everyone. I'm Ana Echeverri. I work with IBM. I've been in the data science and artificial space for about the past 10 years, about 30 years in the industry. And I lead a team of data scientists that build education for clients, continuous learners, and for academia. In particular, I know Jose just mentioned OpenDS for All. This is a curriculum kit that we brought to the market as an open source project. You can find it on GitHub. And it's a collection of modules that allow, really anyone that's interested in building an education offering, whether in the, in an academic setting or private sector, to take those modules and turn them into education offerings, focus on the whole cycle from data preparation to bringing models to market.
Awesome. Thank you, Ana. Welcome. Jennifer, would you like to take a minute to introduce yourself?
Sure. Thank you for having me. My name is Jennifer Priestley, and I'm a professor of analytics and data science at Kennesaw State University. We were actually the first university in the United States to launch a PhD program in data science back in 2015. We teach analytics and data science at the undergraduate, master's, and PhD level, and I'll be talking more about how we're approaching analytics and AI and ML within the context of our master's and our doctoral programs. But we are a heavy contributor to the Open Data Science for All that Ana was just making reference to. And it's really a great resource for any faculty member, again, at the undergraduate, master's, or even the doctoral level, who's just getting started in this space and is looking for curriculum to pull off the shelf and to bring directly into the classroom.
Awesome. Thank you, Jennifer. Excited to hear about OpenDS for All more later in our conversation. Robert, would you like to take a minute to introduce yourself?
Sure. Name is Robert Osazuwa-Ness. PhD statistician, came into artificial intelligence by way of causal modeling and natural language processing. as well as systems biology. I teach courses at altdeep.a, and the courses we teach tend to be very opinionated and pragmatic. And so, for example, as you mentioned, Jose, I teach a course on causal modeling in machine learning. And this is for people who are interested in reasoning about causality, but also are trying to solve problems using a model-based machine learning or a generative machine learning approach to building models and thinking explicitly about the data generating process. We also teach a course on called How to Not Be a Glorified Curve Fitter, which is about taking a very fundamentals-driven approach to machine learning, thinking in terms of inductive bias, in terms of borrowing analogies from information theory, from communication theory, and then tackling machine learning, focusing on decision science, for example. So that's the corner of the market that we live in.
Got it. Thank you, Robert. Appreciate the intro. Torbjorn, would you like to take a minute to introduce yourself?
Thank you, Jose. So my name is Torbjrn Nordling. And as mentioned, I'm an assistant professor at the National Shandong University in Taiwan since 2015. I'm also a senior lecturer in media technology at Umeå University in Sweden since early this year. Now, I started actually teaching AI here at the National Shandong University because 4 years ago, Taiwan launched a major investment into artificial intelligence. And I was part of the early team of scientists here taking up the challenge of making AI a big national platform for innovation and growth in Taiwan. Now, that's, however, not how I got into machine learning and AI. That's a much longer story. So I started by doing my PhD in automatic control, focusing on biological problems, more precisely gene regulation. And having a strong background in physics and mathematics, and then a specialization in automatic control, when working on this problem of network inference, it became natural for me to adopt machine learning techniques and then gradually shift in more and more into deep learning. Now, I would also like to add that in addition to being a professor, I'm actually an angel investor with 6 active investments into into 6 technology companies, of which 2 actually use artificial intelligence as one of the main techniques. So thank you very much, Jose, for inviting me here.
Torbjorn, thank you very much, and appreciate your intro, and again, appreciate you joining all the way from Taiwan. Luigi, last but not least, would you like to introduce yourself?
Sure, thanks, Jose. So my name is Luigi Petruno. As Jose mentioned, I'm the director of data science at a company called 2U, which is actually focused on education in general. And I'm also the founder of mlinproduction.com, which is a blog that's dedicated to collecting and curating and sharing best practices with respect to what it takes to actually build real machine learning systems in production today. The focus there is on systems that are actually in production today and work, and much less so on academic techniques or just on algorithms. We really focus on systems behind these approaches, processes for actually carrying out machine learning based projects and so on. Education is very important to me. I got into, I specifically chose to be a data scientist at 2U because the company is focused on bringing education to the masses through its online platform and through the other aspects of the business. And I was really happy to take my background, not just in the industry, but also as an educator, where I previously taught courses in data science and big data engineering in person, and taking that experience online and teaching online courses in these topics. And I was really happy to partner with TWIML because I know their agenda is really to spread this sort of knowledge far and wide.
Awesome. Thank you, Luigi. All right, so to get our conversation going, I think the first question for our panel is, how did you identify the knowledge or skill gaps that are addressed by the course that you've created and designed? We won't go in any particular order. Anyone who wants to jump in with an answer, please go ahead and get us started.
So maybe I should jump in first then, since I'm focused on teaching an introduction to artificial intelligence to students that actually have no experience in artificial intelligence, nor any experience in programming typically, which is a big challenge. But there's a huge gap actually when it comes to artificial intelligence and also to programming skill among students in other domains. And AI is one of these technologies that I believe will transform every field of science and also every sector of society, because it's an amplifier that enables basically anyone to be more efficient and more productive. So I think it's very essential to ensure that people who are, let's say, social scientists, or people who are maybe even chefs in a restaurant, that they actually learn the basis of it. And what I have identified as the key to getting people into it is to actually provide a course where there's no prerequisites and where I clearly state that, I mean, you don't need to know any programming. I'm going to walk you through the bare minimum that is required for you to actually run a convolutional neural network, and then walk students into having trained, run, and used their first convolutional neural network, so that they suddenly realize, but hey, I have actually done this thing. It wasn't that hard. And that then enables them to learn more depending on interest.
You know, I'd like to build on what Torbjrn was discussing there about this idea of everybody across a university campus having access to machine learning and artificial intelligence. I couldn't agree with you more. It almost seems like an ante to play now in the 21st century, right, to have some literacy in this space. So at our university, we actually are taking a sort of a similar approach to what Torbjrn was just referencing. We actually have a graduate level course that we call Data Science 7900 that any graduate student across the entire university is open to take. There are no prereqs. So whether you're coming out of the humanities, or whether you're coming out of the College of Business, or the College of Engineering, or the College of Science, or the College of Science and Mathematics, or the College of Computing, we bring together students to come into this course from all of these different disciplines, and then we put them into interdisciplinary teams. Because as we all know, once they graduate, that's really the way data science works, right? Is that people work in teams, because there's so many different angles to a data science project, from the extraction and the cleaning and the data engineering, through the modeling process, and then importantly through the communication and the ability to communicate the context and what these results actually mean to the original business problem. And so we put these students into interdisciplinary teams where we try to balance them. So we may have people that are really strong in Python programming and in R and SAS. And then we have people who have zero programming experience, and we put them into teams, and we actually find that they learn a lot from each other as they go through the process of walking the project. Because students that are coming out of the business school have a very different orientation typically to machine learning and to artificial intelligence than somebody who's coming out of the College of Computing. And so we actually find that in many ways they learn much from each other in being in these teams and walking a real world project together, versus if we just had a group of computer scientists, or we just had a group of statisticians working on an initiative. So I agree with everything that Torbjrn said, and we're running some of those same concepts in parallel, maybe with a slightly different flavor.
So if I can hop in, I'd like to take a slightly contrarian perspective. Not to the team's part. I think that bring students in, I found that more opportunities I can create for my students to interact, the better the experience, especially because if you're taking an online course, a big problem is accountability and sticking to the course and taking it all the way through. And so if you can get students to kind of, if you can get students to keep each other accountable, and just in terms of expected weekly calls or group projects, that's a very powerful tool. And there's a lot of tools now with kind of modern social media that people in our community need to take advantage of. I always tell people, like, if you're trying to figure out how to better connect to your students, look to gamers and how they're connecting to their audiences on streaming platforms, for example. But in terms of, so both Jennifer and Torbjrn were talking about kind of teaching courses to people who are new to the space. And with respect to the audience of this panel, which is people who are interested in teaching an ML course, I want to emphasize that you don't have to be one of these folks who are democratizing machine learning. I think that the whole democratization thing is a bit, it's very useful. It's also maybe a bit inflated in the sense that, like, and I tell people, it's like, what about like martingale theory or measure theory? Should we democratize that? It's like, at some point things just kind of have to be hard and you have to kind of want it. And so, and also it's a very crowded space. Like, you got Coursera, you got Data Camp, you got all of these things that are teaching data science and machine learning to people who are new to the space. And if you want to teach an ML course and you really want to have an impact, the more niche and specific you can make the course to faced by a specific audience, I think the more likely you are to be successful. And oftentimes that means teaching more advanced topics. Now that said, when I built my flagship courses, causal modeling and machine learning, I didn't do any actual market research there. I just kind of, my experience has been that things that I'm interested in, I'm fairly not particularly an original person. There's other people who are going to be interested in it too. So if I solve the problem for myself, there'll be other people who will come on board. But that said, once I kind of build that initial audience, I went through a kind of a canonical customer development process with people who were already on my list, and kind of asked them about their pain points and the projects they're working on, and their goals, both in terms of learning and in their career, and since doing, obviously, and from then my course development has been largely driven by those interviews.
Yeah, I think my experience has been a little bit more similar to Robert's than to the original two respondents. When I was creating my course, I was really focused on what are the challenges that I was trying to solve as a practitioner in industry, and specifically as a leader of a team of data scientists who are solving problems day to day. And the bottlenecks that I ran into were essentially what I used as the fodder for what kind of course I'm going to create. Because from what I've seen, there's a lot of sort of beginner material, or there's a lot of blog posts from junior data scientists or new folks in the field, and which is great, and I love to encourage that. However, if you're actually trying to solve these problems in the field, that sort of content is a lot less useful to you, especially when you're dealing with the intersection of algorithms and systems. So I really looked at the types of challenges that we were facing, specifically on things like, how did you deploy these models? How do you take insights that you've generated from your laptop, and how do you actually get these things and embed them into products that end users are going to use? And of course, I'm biased here because those were the challenges and problems that I was facing. So potentially, if I was facing other challenges, my course would look very different. But I used really the challenges that were in industry that data scientists and machine learning engineers are facing on a daily basis, and for which there's relatively little content out there to educate them, as a starting point for my course.
And I will add another view into this process. So at IBM, we're very focused on apprenticeships. So we have programs where we focus on building a set of skills in a combination of education, mentorship, and real world expertise. So we actually took the road of defining, because when you build an apprenticeship, you have to get, that's an official designation, you have to get an approval from the Department of Labor. So we actually took the road of building skills competency models. So it's not so much about what we assume nothing, and we start building up in terms of what are the most basic elements of education that you need to actually get this work done. Some is mathematical foundation, some is computer programming. We use a lot of Python, and then driving down into the specifics for data preparation and building the models, validating models, and putting them in deployment, putting them into production. So we put people through internally through a process where you learn, you get a mentor. And I like to use the analogy of learning to fly a plane, where you take a course, you read the manuals, then at some point you're flying with an instructor until you can fly solo. So we kind of follow that approach where you're being educated, you have a mentor, and then you also have the opportunity to actually start working in projects with supervision before you're ready to do it on your own.
Got it. Thank you, Anna. And thanks, everyone. I think there's a broad diversity of perspectives there, which I appreciate all of you sharing. It sounds like we've got everything from the very specialized niche courses like Robert, Luigi, who are a little more advanced, to a more democratized approach from Torbjrn and Jennifer, and Anna's approach around apprenticeship as well. So appreciate all you sharing those different perspectives. I think a follow-up question I'd have for you is, given your various approaches and also the various needs of education in data science globally, what are your thoughts on how someone who wants to create a course should refine their scope and their timeline for their courses? How did you think about doing that with your course, structuring the length of it, the scope of it, the timeline, and how you approach each of your individual lectures or each of your individual modules, or however they may be structured? Would love to hear more about that. Anyone have a particular insight?
We use a lot the concept of analyzing the different personas because it's, at least for us, we have multiple different audiences, from, enterprise clients to the continuous learner on Coursera to, academia. So we go down the road of first analyzing who are we building this for? And, therefore we have multiple different offerings. So I mentioned, apprenticeship, but we also have, we also brought to market OpenDS for All as a way to get more people to be empowered to building these education programs. So I think the answer is it really depends on what you're trying to accomplish and who you're trying to accomplish that for. And that's kind of the direction that we take.
Yeah, I want to build on some of the comments that Luigi and Robert and Torbjrn made that I think needs to really be highlighted. And that is this idea of responding to the needs of the marketplace. Because ultimately, if in the university ecosystem, if we're not building the skills and the sort of the apprenticeship concept that Anna's talking about, if we're not producing people that have relevancy in the market, then we have a finite lifetime, right? So there's already a lot of challenges for universities. So ensuring that the skills that we're bringing into the classroom are aligned with the needs of the marketplace, I think is a really important foundational concept for any academic who is considering building a course, a new course, whether it's at the undergraduate level, master's level, or even PhD level, in terms of aligning that material with the needs of the marketplace. I think many universities are in cities or certainly in regions that allows them to have corporate partnerships. And it's invaluable to have practicing data scientists who are actually out there doing it. come into the classroom and say, here's some of my data, here's some de-identified data, and here's 3 things you need to know about my data, and here's 6 pain points that I have, and here's 2 things you need to know about my competition, and actually bring that real world data challenge into the classroom to give the students some context around what it is that are actually doing and how what they're doing has relevance in the marketplace. And then I think an important latent benefit to that is the skill that the students develop in terms of communications. So across the board, whether you're talking about machine learning and AI, or if you're going all the way down to just really basic statistical analysis, across the board, these students, these kids, they have to understand how to communicate, how to translate these results back into meaningful information, and ultimately bring relevance to what they're producing in the classroom, what they're producing from these models and from these exercises, and be able to tie it back to the context of the original research problem or the original business question. And again, I think that's a core foundational set of skills, whether you're talking about training at the undergraduate, master's, or at the doctoral level. So, in the context of our university, again, at all 3 of those levels, we lean really heavily into the Atlanta business community to bring executives into the classroom to sponsor analytics, AI, machine learning projects, to give the students that context and to actually walk a project with an executive, with a practitioner of data science, because that's so much more relevant and so much more powerful in terms of the educational experience versus just downloading a data set off of Kaggle and just having them try to optimize a classification rate. So, I think we shouldn't lose sight of how important those communication skills and that those practical skills are in the context of this larger conversation around building courses in AI and machine learning.
Yeah, I think I also have a similar take to some of the things that were already said. And specifically, when I was starting to design the course, I was really focused on like who the course was for, right? Because I wasn't trying to teach everybody. I was really trying to teach the practitioner, somebody who already has a job, somebody who's already in the market to solve a problem that he or she has. So this could be mostly data scientists who are working on modeling problems, but it could also be ML engineers who are trying to maybe take output from a data scientist and operationalize it, or even folks on DevOps who are focused on operationalizing software in general. The first thing is that since these are people with jobs, I really want the course to be something that's accessible to them and not sort of too much work, right? So thinking that we were going to meet weekly for some number of weeks, want to try to frame it so that there was a good amount of material, but not so much where the person would be overwhelmed and lose interest and potentially drop out, as Robert sort of alluded to earlier with completing courses. And on top of that, there's also a pretty, I wouldn't say completely standardized, but there is the beginnings of a process model for actually completing machine learning projects in industry, where you start with like an initial exploratory phase / product scoping phase. From there, begin to do some data exploration, build some models, and sort of enter a feedback loop where you determine, if these models satisfy whatever KPIs and metrics you set up originally, and then move on to sort of a deployment phase and a monitoring phase after that. And some people may be familiar with something like the CRISP DM methodology, and it's very similar to that. So I really chose to sort of structure the course as if it were a machine learning project that you were doing in industry, and each of these stages that you would eventually be sort of cycling through. Intention being, use the format of the course sort of as an educational mechanism itself, because for those people who are in the industry, they may or may not be familiar with these types of frameworks, and just the way it's structured may be an additional way to learn something or teach these students something else.
I would like to echo something Jennifer said. Like I also in my course, I have a lot of industry on projects that where students have to communicate something to the rest of the group. It's funny how with the kind of coinage of the word data science and to kind of a new epoch in machine learning since deep learning kind of gained traction in the last, I guess 7 years or so. But is that we're kind of inventing things, or we're rediscovering things that were already there. Like in most statistics programs or statistics master's programs before data science was a thing, it was a consulting degree. Like that's why when you went in, that's why if you were in graduate school, you knew that the statistics department had a statistics help desk. That was their basically their internship for being a consulting statistician.
Mm-hmm.
And as we kind of invented data science by combining statistics with software engineering, we thought of it more in terms of a technical skill set and forgot the fact that, oh wait, there's no one way to solve this problem, and you need to have people who can go and understand the client's problem and what they're trying to solve and how the data is generated, and then can communicate clear insights back to that client. And it's funny how we've lost that, and we're now having to rediscover it.
Mm-hmm.
So, Robert, I think you captured one of the most essential things when it comes to all types of ML and AI education, and that's specialization. Because there's a lot of material online, but despite that, we are all individuals. We have all different backgrounds and needs. So we actually need to provide material in very different formats for different students in order for it to fit them and to attract them. Now, I think several of you have also highlighted the importance of having problem owners come into data science, and because what I have seen is that people who are really into data science or machine learning, they typically are not problem owners. They don't know actually the problems in industry, in society, where the technique could be beneficial. So what I believe is that we need to actually get the problem owners to learn enough machine learning, data science skills so that they have the language to be able to communicate it to then specialists in data science and machine learning in order to really be able to address problems where it would benefit society greatly to have the technology deployed. And there's already, I think it's like 4 or 5 years ago, McKinsey published a report where they claimed that approximately half of all the tasks carried out could be automated with existing technology. However, in that report, they also predicted that it would take between 30 to 70 years to reach that state, if I remember correctly. So adaptation of a technology is something that takes a long time. And I believe one of the reasons for why it takes such a long time is that you really need to get the communication between problem owners and those who have the skill set to really deploy the technology working. And that actually means educating both sides a bit. So what I chose was to focus on educating the problem owners, the bare minimum. So my starting question was actually, okay, so what is the data set, the problem that essentially all machine learning people who are working on deep learning know? Well, that's probably MNIST. So my starting point was that, okay, to then train a convolutional neural network to recognize digits, what's the minimum amount of knowledge needed for this, both in terms of Python, in terms of understanding statistics, and then I put together this minimum material. And then I asked myself, okay, so now I have the minimum and I have a path to actually ending up with a trained convolutional neural network for digit recognition on the MNIST dataset. Now, what should I add in order to enable the student to realize that there's much more to learn and give sort of a teaser so that students know what to look for when they want to learn more. Then after this, well, I'm at the university where we have an 18-week semester. I simply distributed this in 18 weeks.
Mhm.
So this is how I designed my introduction to artificial intelligence. And I think based on having run it now for a few years, that it's actually an approach working surprisingly well.
I
Great.
have a question for you, Torbjrn. So one challenge I see with what you're doing is, so okay, let's say we're going to teach a covenant to a domain expert. Say, for example, somebody, say a radiologist who's diagnosing lung illness from X-rays, right?
Mm-hmm.
So you teach them on MS, and now hopefully they can go and extend it to these real world kind of problems. But then, once you get into production, maybe for one reason or another, it doesn't work, or it does work and people want to understand why it works. And those people, despite having the domain knowledge, can't explain why it fails or can't fail, or doesn't, or why it fails or doesn't work, why it works or doesn't work because of just the of a covenant, right? Like in terms of the hyperparameters, in terms of like why does accuracy increase this much if I change, if I shuffle my data before I before I train the model? I think that when it comes to bringing in domain experts, we face a fundamental obstacle in this area, in AI as a space where we tend to be biased towards models that aren't particularly explainable, or rather where the syntax of the model just has no mapping to the semantics of the problem. And so no matter how much you understand a problem, you still hit that barrier. I'm wondering what your thoughts are on that.
So I love that you are highlighting this, Robert. So first, I would like to start by saying that my aim is actually not to make problem owners into machine learning experts. My aim is actually to teach them what's possible, give them the confidence that, yeah, okay, these things contains a lot of things I don't really know exactly how it works, but I can actually accomplish something. And then to teach them the language to communicate with people that are actually domain experts at machine learning and deep learning. Because when it comes to this fundamental problem of explainability of the models, then even the domain experts can often not explain, okay, why is the model giving this prediction? And that's actually one of the big weaknesses when it comes to deep learning. And I would actually like to say that deep learning is great for prediction. So I would recommend any person who have a problem where you just need to make a prediction of or a forecast today, apply deep learning if you have a lot of data. If you don't have a lot of data, well, then you need to turn to more traditional time series modeling, for example, or system identification techniques due to lack of data. But doing that requires a lot more training and skill to get a good model than to train a deep neural network. So a deep neural network is actually something that a person with relatively little skill compared to what's required for applying traditional system identification techniques, which are commonly used in automatic control, which is my home subject, so to say, where I started. So that makes it a first to go, but that will only bring you to a state where you can make great predictions if you're successful. You will not typically really understand why it's making the predictions. And if you want to answer that, in other words, you want to gain mechanistic insight, well, then in many cases, it becomes really a research problem, and we need to move away from deep learning and go over to traditional modeling again, where we actually have control over the degrees of freedom. What can the model do? What part of the model can produce a certain behavior? But that really requires a lot more training, a lot more skill. So to summarize it up, what my aim is really to give problem owners the confidence and the language to be able to interact with experts.
That's a great perspective there, Torbjrn, and Robert, appreciate that question. I think that sort of highlights for all of us, right, how regardless of what course you're thinking of developing, what specific area you'll teach the audience that you're developing your course for will depend on their understanding of machine learning and data science, their understanding of more of a, right, of the business side of things, and then how you then select what subject matter to teach. I think, I want to make sure we make the most of our time, so I want to make sure we have a chance to talk also about resources that you use to develop your courses. In particular, are there any resources that were particularly helpful to you in developing your courses, not only from a content perspective, but also from a student engagement and learning perspective? So I'd love to get all your thoughts on that as well.
Yeah, I can jump in here. In the context of this course that I've made reference to, this data science course where we bring in the students in the context of interdisciplinary teams, again, we tend to partner with businesses, and they'll come in and they'll present us with their data, and they'll present us with their question. And what's kind of fun but challenging about that course at the same time is that I never know exactly what techniques or what approaches we're going to need to solve the problem. I don't know how much data we're going to have. I don't know if we're going to end up doing something as simplistic as t-tests and multivariate analysis, multivariate modeling, or if we're going to end up doing something like neural nets and deep learning, right? I don't know what we're going to have on the first day of the semester. And so it becomes a little bit of an a la carte teaching approach. So once the project sponsor comes in and they articulate the research problem, and then we have a chance to do some data discovery and go through the process of understanding what we're facing, then we kind of open up the toolbox and say, okay, guys, across all of these tools in machine learning, AI, data science, let's talk about the pros and the cons of each one of these approaches to this data project. And so in the context of trying to pull from multiple resources, I found the Open Data Science for All initiative that IBM has put together to be particularly helpful, especially if we're talking about these entry-level type courses, these introductory courses, or these more broad-based courses that bring in people from multiple disciplines, because it is set up as sort of an a la carte toolbox, where you don't have to use everything that's out there. You can just pull this semester, you can just use the k-means classification, and then next semester, you can pull in the deep learning module. This one's written in Python, but then you could also potentially go out and use this PowerPoint, but then pull programming from SAS or from R or from some other resource. So, I just big shout out to IBM and to the Open Data Science for All, because it has been set up as a modular toolbox for academics, and I would say probably at the level of kind of lower master's level or really higher level undergraduates.
Awesome. Thank you, Jennifer. And I think I did drop the link to OpenDS for All, both the website and the GitHub, in the chat for anyone who's interested there. And yeah, it sounds like the vision for that is to provide a curriculum or a template so that anyone can create a course in any of those particular modules. So does seem like an awesome tool, and highly encourage everyone to check it out. How about the rest of the folks? Any particular resources that were helpful to you in developing your courses?
So I would first like to start by saying that, Jennifer, I really like that you're taking on the challenge of allowing the problem owners to bring in any problem to your course, because that's a big challenge. I have a master course where I'm teaching on model selection and network inference. where I allow the students to pick any problem they want related to model selection or network inference. And that means that I have no idea actually what I will be teaching that year.
Right. It makes it that much more challenging, doesn't it? Because we can't flip to the back of the book and check the answer.
Exactly.
I like to say we're building the car while we're driving 90 miles an hour.
Yeah, yeah. And that's something that that I love to do, but it's not, it's only a thing, you know, that I think makes sense for us teachers to do within a domain where we have a very broad knowledge and where we are really experts. Now, jumping over to the actual question that Jose asked, so what tools are the most useful? I would like to say TensorFlow. When it comes to my course, TensorFlow is without any question the most important tool that we are using. Being the most widely used tool for deep learning, I think that's what I have to teach. Now, of course, TensorFlow is not the only thing being used. I'm also then, since this is an introductory course, it means typically none of the students even know what the version control system is. So I'm teaching them a little bit, giving them an introduction to Git. And then, of course, Python, if we didn't have the language, the programming language itself, then we couldn't do things. So when it comes to giving credit and stressing what tools to use, I think it's important to also stress these very fundamental tools, which we often tend to forget because they have been around for a very long time and we use them all the time. But they are actually what enables us to do the things. They are the shoulders of the giants that we stand on and build upon.
Got it. Thank you, Torbjrn. Anyone else have any thoughts? Robert, Luigi, Anna?
Yeah, I mean, you know, a large part of my course is focused on a specific tool, right? It's focused on a specific technology, which is AWS's SageMaker. So clearly the course wouldn't be possible without that. And SageMaker itself is built on a lot of other AWS services. So clearly the AWS you know, web services infrastructure itself is necessary for the course. But I'd say to like abstract away a bit from the specific technology, I've referenced a few times these process workflows for actually getting projects done, things like CrispDM and several others out there. So having an understanding of those, because of how they chart out exactly how an ML project will be completed, you know, in production and industry, an understanding of each of those steps in the pipeline, I think is like super critical for the type of course where I'm teaching. So not just the specific technology that AWS is offering and that I'm teaching, but some of the standard methodologies for carrying these projects out was very helpful for me, just because it helped to really hammer the point home that this is how projects are getting done. These are the types of this is the type of language you should get used to, and the types of workflows that you might see in industry, or that you already have seen in industry if you're somebody with a job. So those are the two of the biggest things that were most helpful.
For us, specifically as it relates to OpenDS for All, I think we had some guiding principles more than anything else. Like, we wanted this to be open source because we wanted to ensure that it was, you know, that we could do an initial contribution and then the community would continue growing this curriculum kit. So that was one of the guiding principles. We wanted it to be technology agnostic from the perspective that it's not IBM technologies. It's 100% Python, 100% open source, because we wanted to make it available to literally everybody. I mean, and anyone can run a Python Jupyter notebook on a laptop. So that was kind of one of the elements that we wanted to bring forward. Now that we have this initial contribution and in this initial foundation, what I love to see happen for OpenDS for All is the community coming back to it and contributing content back. Specifically around, there's been a lot of conversations here about the value of the specific use cases, right? Developing that expertise of a business problem, a data problem, and then maybe a machine learning solution tied to that. So we are actually going to be building an additional bucket within the taxonomy so that we can get additional contributions around use cases. So those were kind of the guiding principles that we had from the very beginning.
Got it. Thank you, Anna. So I think, I know we are running short on time here, so I think maybe I have one more question for the entire panel, and that's more around your thoughts on the future of developing courses in the INML, given all the changes that are happening right now due to the COVID-19 pandemic, and how that has changed education, and how that has changed your strategies for student engagement as well, and how what you're doing to address that, or how you're moving forward with that. So would love to hear your thoughts. Whoever would like to go first.
I think that there's, if you look at kind of places that are kind of, as they say, ripe for disruption, I think one is due to COVID. Obviously there's healthcare, and the other is education. I mean, we know now that that universities have had a certain model for, and I work at a university, so I'm playing, this is inside baseball here, but have had a certain model for advanced education. It's now being challenged by times that we're living in. I think what's going to happen, we're going to see we're going to see the tech industry probably make a lot more incursions into this space. If, for example, Google were going to say, hey, come get a Google master's degree and then, leave here and get a job at Google making, $300,000 a year. That's going to be a really tough thing for a lot of universities to compete with. So what I think of as an entrepreneur in this space is, okay, like how do I position myself to take advantage of that change? And I have ideas, but suffice to say, it's a very exciting time to be building online education in this space.
Yeah, I would echo something that Robert said, especially with his background, which is more similar to mine as a sort of an independent person creating courses, not really affiliated with an institution or a university. There's a lot more opportunity than there ever was before to create your own online course or to create your own set of online courses. But I'd say that in an industry such as ours, there's a lot more competition than ever before from some of these huge institutions, right? So as Robert mentioned, if Google decides to put out one of these master's programs as a sort of funnel into their company for employees, it'll be really hard to compete with that as an individual contributor. However, as an independent person creating a course, but that really opens up a lot of opportunity for you as a niche player. So if you have a particular set of expertise, a specific set of expertise, you're not trying to build just a general course. I think there's a lot of opportunity for people who have been working on these niche problems to build their own audience and to then create courses and market those courses to that specific type of audience. And the more niche and the more specific you are, the better it is, I think, because there's just less of an opportunity for large institutions to do land grabs there.
And I would, to add on to that, Luigi, I would, my call is to people who are running, departments at universities, like Jennifer, for example, who are innovating in this space. Folks like Luigi and I, we can't issue diplomas, but we can give you, there's opportunities for collaboration where we can give very kind of niche content to advanced users. I think I think one kind of really interesting area will be people who aren't permanent faculty, who are in some kind of degree of adjunct or something like that, kind of program specific audiences of people, and then being able to plug into the resources of a larger institution. That's I think.
Yeah, I mean, the company I work for, during my day job is all about bringing education online. So I have a firsthand look into like just the amount of investment you need to make to generate content at scale for online master's programs, and the investment is quite large. And in a field that's changing as quickly as AI is, you need to refresh that content very regularly and very quickly, and that's a very difficult scale problem. So that's a really interesting idea you bring up, Rob, where universities can partner with independent folks to help keep their content up to date and relevant.
So I would like to also echo the fact that specialization and offering niche content, that's a really huge opportunity, because traditionally, and I would say largely still today, what most university professors do is that they offer the 101 electronics course, or the 137th mathematics course, linear algebra, for example. So I think, so traditionally, every university have more or less been offering the same basic courses. I think now, thanks to online education, I foresee that universities will also start specializing more on professors. I mean, why should I make the 107th calculus course when I instead could make a niche course that then can be broadcasted globally to the people that are having that specific interest? I think this will really increase the opportunity for people to learn. And I think this will be essential to really enable everyone to learn almost whatever they want. So I think this is really a big revolution that is going to change education. Now, the big challenges, which I don't think anyone yet know how to solve, is how to make online education truly engaging. Because many students now that suddenly have had to go over to online learning have, at least to me, been saying that, oh, it's so boring. I mean, in Taiwan, we are very lucky. So I would say Taiwan is probably the country that has handled COVID-19 the best out of all countries in the world. Taiwan has around 500 infected in total so far, 7 deaths. And we only in the beginning of the pandemic had some small local clusters. There's no local outbreak of COVID-19 here at all. The people that, a majority of these 500 are actually people coming from the outside, flying in, and then when during their 2 weeks mandatory quarantine, it's detected that they have COVID-19. And since we have mandatory quarantine, they can't spread it in society. So that has meant that a few of my previous bachelor students that now are doing masters in the US, for example, have actually returned home to Taiwan, because why should they be in the US and spend a lot more money just to sit alone in a room watching online courses, when they instead can be in their home country where they can move around freely and where it also happens to be a little bit cheaper to live. And what they have been telling me when we have been meeting is that it's so boring to watch these online courses. Actually, even one of them, he decided to enroll here and take the physical education instead of continuing his education in the US, his master's program there. So that's really a major challenge. The other major challenge I see is that as we create a lot of specialized niche courses, how can we communicate in an efficient manner in which way it's specialized, whom it's suited for, and reach the right target audience for it? These are the two main challenges I see. And I would like to hear your ideas for how to solve them.
Got it. Thank you, Torbjrn, for sharing that. I think that there's student engagement is a critical part of what needs to be solved. I know we're at time. I would love to get Anna and Jennifer's thoughts before we close out, if you have a minute. Robert, I know I understand you need to go right away, so no worries if you need to drop. And if everyone else needs to drop, completely understand as well. But if not, Anna, Jennifer, do you have any thoughts to close out our session?
Goodness, there's so many topics that we've covered. I would just say that the fields of analytics, data science, machine learning, AI, kind of in this larger ecosystem, the discipline has just exploded so broadly, so quickly, that it's been again, like building a car while you're driving 90 miles an hour, right? For most universities and most people that are in this space. And so unlike traditional disciplines like mathematics or chemistry or biology or computer science that have these very well-worn accreditation processes, it's sort of the Wild West right now as it relates to analytics and data science. And so we don't see necessarily consistency in terms of how these concepts are being taught, not only in terms of universities, just within universities, like in the university ecosystem, but then more broadly, when you start talking about, again, like the Googles and the Amazons and how they're teaching within their organizations. And then when you get into independent educators as well. So we're not seeing much consistency across the ecosystem. So I see that as an important point of conversation for all people that are engaged in this space professionally, is to think about what we want as we move into the next generation of AI and machine learning. What do we need to be incorporating if we do want to make this truly an academic discipline for the next generation? What does that need to look like?
Got it. Thank you, Jennifer. Anna, any other thoughts?
I would just like to invite the audience to visit OpenDS for All on GitHub and check out the resources. I think there's a gigantic opportunity in this field. I think as Jennifer was saying, we may not have clear frameworks and full definitions of what the field entails, but it's a very wide field. And, once you start breaking it down into its components and into its use cases, into its industries, into its type of business challenges, I think there's a tremendous opportunity for all of us that are working on trying to build educational content to try to come together, right? And find those, what is that right consistency? What is the right consistent level of learning outcomes that we want to achieve, and maybe work more as a community than each of us in our own little worlds.
Great. Thank you, Anna. All right. Well, I think we're out of time. Any final words from our panelists? Anything else you'd like to share? Any departing thoughts?
This was great. Thank you so much for putting together such a diverse panel. I think everybody was coming from different orientations and different perspectives, which always makes for a very robust and rich conversation. So thank you, Jose.
Awesome. Thank you, Jennifer. Yeah, thank you to all of our panelists, Anna, Jennifer, Robert, Torbjrn, Luigi. We really appreciate your participation. We appreciate you joining us at TMOFest. And to those of you in the audience, we encourage you to check out OpenDS for All and check out the work of all of our panelists. You can see their bios on the TMOFest website, and encourage you to check out the remaining TMOFest events that we have going on today and tomorrow. Everyone, thanks. Have a
Thank
good
you
night.
very much.